class, we talked about kind of how we'll be using our days between now and our mock exam / AP. This is still a work in progress, but I want to kind of give you the idea of what I'm thinking here. So last class we did a little bit more with differential equations in terms of response. That's probably our most familiar or most recent topic. And then we did our multiple choice topic, wellness continuity. So if you're absent, you can grab it from the minute there. And last night you had multiple choice topic 2. Apparently I didn't give you all of it, so we're going to do some of it for warm up. Hopefully what you had was really easy, right? Super fast, not too bad. There's no related rates on it. Whoops, that's on the piece we'll do for warm up. So today we're going to do the rest of topic 2. And then we're going to do free response, grade and grade out problems. And then tonight your homework will be multiple choice topic 3. So I'm going to pass it out to you. All right, now I'm going to go and give you our multiple choice topics. So you'll notice your homework is multiple choice by topics. So I just went ahead and printed it all in one packet. So that's coming your way. And then during class, we'll go over our multiple choice questions that we have. And then we're going to take a look at responses by topic. And I printed all those out together as well. So you'll be getting a couple packets today. And then again, our AP mock exam, which is our final exam, will be the Monday and Wednesday before spring break. And then on that Friday, we'll just be doing some more review, spring break. And then when we come back, we'll go over our mock exam. And then this is still to be determined. These are the days in between going over our AP exam and our actual AP exam, but I lose some of you guys starting here. So this is to be determined what we'll be doing from there. But at least you have an idea what's going on.
Remember you said you promised me to watch a movie one day, have a math part.
You mean before AP exam?
No, you got to study afterward.
I'll think about it. Okay, and then just keep in mind your cross-section project is due Thursday. Today during Stingers is going to be a work day for it. You can have me double check your integral and your set just to make sure you're okay with that. And if you're equilateral triangles, I'll tell you with the compass how you can do those. I think it's my thoughts there. Great. So let me go and pass out your multiple choice topics. Okay, so what you have in front of you, this packet, it picks up with the rest of topic 2. And then you'll notice it has topic 3, 4, 5, and 6. So as I'm coming around to check your homework, why don't you go ahead and work on the rest of topic 2. So this is topic 2, derivatives part 2. You don't have to do that for your response at the end. Right now I want you to just kind of focus on this multiple choice. You're allowed to kind of bounce around if you want. There's some related rates. And there's some implicit differentiation, line tangent to the curve. Yeah, so go ahead and work on that. We'll take probably like 15, 20, 15, 20 minutes on that. So again, don't forget about your double angle identity. We used our double angle for sine. Does anyone remember what the double angle for cosine is? What'd you say? Yeah. Cosine squared minus sine squared. Okay. So on to 18. Here, is that a question or a stretch? Okay. Alright, so here we have cosine x equals e to the y, and they're asking us for the derivative, so we're going to have to do some implicit differentiation here. Or we could rewrite it. I'm going to just first try implicit differentiation. So we could have done the log of both sides, but I'm going to first try implicit. So I have cosine x equals e to the y. So the derivative of cosine is negative sine x. Derivative of e to the y will be e to the y dy dx. So then dy dx equals negative sine x over e to the y. It's not one of our answers, is it? Yeah, we're going to have to substitute, don't we? So we have e to the y is cosine x. So then let's substitute that in. Negative sine x. E to the y is cosine x. And what's sine over cosine? Okay. So the other thing that I said we could do is that we could rewrite this. So if I take natural log of both sides, I don't know if that makes it any easier. Natural log of cosine of x. Natural log of e to the y would be y. And then do your derivative there. So my derivative would be natural log is 1 over our argument times derivative of our argument, which would be negative sine x. And then that would simplify out. Any questions with that? Okay, so don't forget about those substitutions for sure. Okay, so then let's go 21 and 22. Okay, so 21 we have a balloon that apparently is spherical. It says it's being filled with helium at a rate of 4 feet cubed per minute. So this is going to be my dV dt. Remember, if you're not certain what that represents, take a look at your units. The fact that I have feet cubed per minute, that's going to be my volume per time. All right, so it's being filled, and that's it's being filled, so it's going to be a positive 4 feet cubed per minute. The rate in square feet per minute, at which the surface area is increasing and the volume is 32 pi over 3 feet cubed is. Okay, so we're trying to find the rate at which surface area is increasing. So we want to know, let's say the SAT, when our volume equals 32 pi over 3. Okay, this is what we want. So let's start off with our formula for volume. I'm going to use my space up here. So the volume of a sphere is 4/3 pi r cubed. Surface area is 4 pi r squared. Take the derivative volume. What do you get? Say again? Close. Very, very close. When we bring that 3, that would cancel out that. Right? So 4 pi r squared. So notice the derivative volume is just surface area. And if you think about it, well, do I want to go down that road? We'll just pause there. Our derivative volume is surface area, which I think is an interesting connection there. Okay. So we have dV dt. So I'm going to take a look at that. So I do dV dt. Oh, we brought that right there. So I just have to say we have 4 pi r squared dr dt. Alright, and we're trying to find our surface area here. So I'm going to go and do my derivative for that. We're in surface area with respect to time. So we would have 8 pi r dr dt. Okay, and let's see what information we have. We have that our volume is, our rate at which the volume is 4. So that this guy is 4. And it says when the volume is 32 pi feet cubed. All right, so we want to know when our volume is that. So let's use that to solve for R. So when our volume is 32 pi over 3. Multiply both sides by 3, it gets rid of our 3's. Divide by 4 pi, would you guys agree it's 8 equals R cubed, so then R is 2? Are we okay with that? So when volume is that, which means when R equals 2. All right, so now let's see where we can go from here. So we're trying to find our surface area at that time. So let's plug in what we do have. Okay, so we're trying to find this guy. I know it's when my radius is 2. But I need to find dRdt. How in the world do I find dRdt? Let's take a look at our other equation. We have ddt. We're looking at when R is 2. So we can plug those values in to solve for dRdt at that point in time. So we have the change in volume the entire time. We're looking at that moment in time when radius is 2. So plug that in, we can find what our rate of change is at that moment in time. So doing that, 4 equals 4 pi. My radius equals 2 squared dRdt. Let's see if we can use the math here. Divide by 4 on both sides, that's 1. dRdt equals, is it 1 over 4 pi? That doesn't seem very nice, does it? Alright, so then that's what we're going to put in here. It's 1 over 4 pi. And again, we're looking at the rate of change surface area at that moment in time when radius is 2. Same thing. Alright, so let's go reduce. Pi is reduced. Let's see, I've got 8 and 4 reduced to 2 and 2, so 4. Please say the answer was C.
Yeah.
Was it actually Garrett, or are you just saying that? So here we had to use those two equations, and really it's just substituting in what you have from here. Questions with 22? And then 22, I think, was our other related. Water is being poured into a conical reservoir at the rate of pi. Why do they have to write it out like that? It's so weird. Pi cubic feet per second. The reservoir has a radius of 6 feet across the top and a height of 12 feet. At what rate is the depth of the water increasing from depth of 6 feet? Okay. I've got a draw picture. Water's going in, so if we're talking about it going in and we're looking at cubic feet per second, what are we talking about here? Volume, good. Okay, so my dVdt at the rate of pi, so and we're increasing, so it's positive, pi cubic per second. Reservoir has a radius of 6 feet across the top and a height of 12. At what rate is the depth of the water increasing to the depth of 6 feet? Okay, so we are looking for, I'm going to call the depth of the water, I'm going to call that H. So I'm looking for dH dt when H is 6. Okay, so as we have water being poured in, right, so there's water going in, here's the water droplets going in, the water is rising here. And so we have, with this type of problem, we have the similar shapes, so we're going to set up our proportion. Just say radius to height. Okay, so I have my radius to height equals 6 to 12. I'll probably need to use that. Then we need our volume formula, it looks like. Anyone know their volume formula for a cone?
1/3 pi r squared h.
Very good. 1/3 pi r squared h. So what this is our volume of a cylinder. Our volume of a cylinder is your area of your base times your height. So this is our height here. Now our area of our base is pi r squared. Okay, so this is our formula for area of the cylinder. Cone is just 1/3 of that. Same thing for a pyramid. If you were to do the area formula for a rectangular prism, and then do 1/3 of it, that's your pyramid. So that might be helpful if they don't give you the formula. Sometimes they do, sometimes they don't. So you want to be aware of pretty much sphere and cone seem to be their these favorites, volume and surface area. Okay, so we've got our volume formula there. Since they gave us the rate for volume, let's go ahead and, before I do my derivative, I don't want to have to do with the product rule of all this, so I'm going to go and do a substitution. Now, I want to keep H, I want dHdt and I want H, so I'm going to substitute in for R. Let's reduce this guy here. This is 1/2. Multiply both sides by H. So I get my radius is H over 2. Alright, so I'm going to go ahead and rewrite my volume formula there. Volume is 1/3. I'm going to put my pi on top. My radius squared is H over 2 quantity squared is H. So I have H cubed over 4. So I have pi over 12 H cubed. Okay, so here's my volume in terms of height. And let's go and do a derivative. So dV dt equals pi over 12. I bring down my 3. I reduce pi over 4. H squared dH dt. Do we have questions so far as to what I've done here? Alright. So now once again I'm wanting dH dt, so I want this. Specifically 1H is 6. So I want it 1H is 6. I'm going to substitute that in, and they gave us our dV dt. So now we're just substituting and solving. So I have dV dt is pi over 4. And that H squared, so it'd be 36. dH dt. This reduces down to 9 pi. Right, so let's go ahead and write this out. Divide by 9 pi. So 1/9 is dH dt. Got it. Is answer A?
Yeah.
I love it when related rates work out nicely. So again, the second equation that you needed for this was when you have similar shapes. Pretty much anytime you have a container that is being filled with something, you're going to have to do those similar shapes, or you set up your ratio there. Because you have a standard information about the container, and then the change is usually with the water, the gravel, or sand, or whatever it is that they're filling it up. Okay, questions with those? Okay, we're going to transition to free response now. So our free response that we're going to look at today, I already passed out free response, right? Look at this packet. Okay, so this packet here is all the free response. Last class we talked about, I showed you guys the breakdown of from 2015 to 2018. Our free response kind of fall into 5 categories and then an oddball category. So we have differential equations, which is our first one here. And then it goes, you can't see the title because it's in the corner exactly where the staple is. So if you want to write in here, this is rate in, rate out is our second page. Then function analysis charts. Then function analysis graphs, then it got cut off again. And then particle motion. So those are our 5 categories that every year it seemed to be that there was, almost every year they had a question in each of those categories. And then the last page is our other category. And again, other is right where that staple is. So I put O's on those, you know. So these are the questions from 2015 to 2018 by those categories. And I told you guys last time that the teacher previously had looked at the questions from 2010 and 2014 and kind of chunked those up by categories and came up with basically the same categories. So it seems to be guaranteed for us if we're going to have a differential equations. Now, not guaranteed, but most likely, AP could always go bonkers and do something different. But most likely, you're going to have a differential equations. So we took a little bit of a look at that last time. A rate in, rate out. Function analysis graphs, function analysis charts. So function analysis is like increasing, decreasing, max, min, concave up, concave down, things like that. And then particle motion. And then the 6th category, there's a combination of things. I've seen volume and area that used to be a standard category. It seems like they've taken a bit of a step back from there. So volume rotations is one. sometimes I noticed a lot of chain rule and quotient rule on those ones. There's one year they asked me about a limit. So that last page is kind of the other category. You don't know what that 6th question is going to be. So last class we took a look at differential equations, which is the most recent thing we've done. Today I want to take a look at our second page, rate in, rate out. So go ahead and turn to your second page with it there. And the specific ones that I want you to look at. So again, what you have in front of you is the questions from 2015 to 2018. And I want to look at 2018 and 2017. Okay, so this is the first one that you'll see there. This is 2018. This is question 1. So just a reminder, questions 1 and 2 are always calculator questions. So this was a calculator question. And here we have people entering a line for an escalator. So this is our rate in here. Say rate in. So it says rate, but we've got rate in adding to the escalator. And then it says, and also too, if you're not sure if it's rate, look at what the units is. People per second. That is a rate. And then as people get on the escalator, they exit the line at a constant rate of 0.7 person per second. Part of a person gets off that escalator. All right. So this would be our rate out. It's a constant rate out. And then they tell us this initial condition here. So this is kind of your basic setup. We have a rate in. We have a rate out. Now notice I'm going to show you these kind of 2 questions I think cover a lot of the different types of things we'll ask. So for 2018, they asked just how many people enter the line from 0 to 300, and then how many people are in the line at time 300. And then after 300 minutes, or 300 seconds, what is the first time that there are no people in line for the escalator? And then part D, I want to really draw your attention to. So this is max as an absolute maximum. For time 0 to 300, at what time is the number of people in line a minimum? So the nearest whole number, find the number of people in line at this time, just find the answer. Whenever they give you an interval and they ask you max or min, that means it's going to be an absolute max or min. You've got to check those endpoints. So they aren't going to explicitly say absolute max or min, they will just give you that interval, and this indicates you need to check absolute max or min. So you're going to do your relative max mins, and then you have to check your endpoints as well. And when we're talking about justifying, that's that chart. You find, first of all, you take your first derivative, set it equal to 0, find your critical points, and then you set up your chart with your endpoints and those critical points and find those values. That's your justification for it. Okay, so now let's take a look at 2017 rate in, rate out problems, the one right next to it. Let me pull it up here. Is it the bananas one? Yeah. Okay. So here we've got some bananas. And so at a grocery store, it has 50 pounds of bananas on a display table. So here's our initial condition. Customers remove bananas from the table at a rate multiplied by this. So this is the rate out. And then it says after the store has been open for 3 hours, they start to add bananas in. So here's our first one's our rate out, second one's our rate in. With all of our 3 response questions, we really want to make sure we are naming the functions by name. Refer to this as f of t, refer to this as g of t, especially in your justifications. Make sure you don't say it or the function. What function are we talking about? If you don't name it, if you don't say it by name, they're not going to give you points for your justification. All right, so here they asked how many pounds of bananas are removed from the table during the first 2 hours. So it's kind of similar to what we had in 2018 where they asked for a total amount. How many people entered the line? How many bananas were removed? Part B here, it says find f prime of 7, and then using correct units, explain the meaning of this in the context of the problem. C is the number of pounds of bananas on display increasing or decreasing at this time. So this is another type of question I'd like to ask. And then part D, how many pounds of bananas are on the display table at time t8? So these are just common types of things that I'd like to ask. And something I want to remind you of is when they're asking for an amount, how many pounds of bananas are removed? Over here, how many people enter the line during that time frame? When we integrate a rate, that's what gives us our amount. So integrating a rate gives us our amount. So if we were integrating the rate of bananas removed, bananas removed, our rate is bananas per, not second, minutes per hour, pounds per hour. So when we integrate our pounds per hour, we're going to get the amount of bananas that were removed, the amount of pounds of bananas that were removed. So when they ask you for an amount, just remember you want to integrate your rate. Now, obviously, depending on what they ask is going to determine which rate you're integrating. Okay. So when you encounter your free response questions, it is 15 minutes a question. The first 2 are calculator, and you get 30 minutes to go back and forth between the 2. The next 4 are non-calculator, you get an hour for those. What I want us to do, let's see, we're going to go a little bit into Stinger, but I want to take, we'll go, I'm going to say 30 minutes, but I'm going to check in at 20 to see how we're doing, because sometimes we don't take the whole 30 minutes. I don't want you guys just sitting there for 10 minutes waiting for time to be up. But obviously when you get to your free response, you don't get to preview this like we have here before starting your time. But I wanted to draw our attention to some common things we see with this and some answers before we start. Notice that these are both, this was question 2, and this one was question 1, so these are both calculator questions. So if you need to borrow a calculator, I have them now. So let's go ahead, and what I want you to do is we're going to go here and just present it as the actual AP response. I'm going to have you complete this, and then we'll take a look at your grading rubric and grade ours and see how we would have done it. Yeah. Okay. So again, let's just take 30 minutes, hopefully less, to do both questions, and we'll go over it. Key reminders: make sure you label it, call it by name. Always show your setup, even though you're doing it on your calculator. All right, so go and take 30 minutes or less, and go. And guys, you can do this on your own separate notebook paper if you want, or on the paper itself, wherever you feel like you have room or want to put it. All right, so 2018. Let me pull it up here. Okay, so our escalator one part. Am I looking at it? Yes. So part A, how many people enter the line for the escalator during this time frame? Again, whenever we're wanting the amount of people, then we want to integrate a rate. And if we want how many have entered the line, we want to integrate the rate coming in. Part B, during the time frame, there are always people in line for the escalator. How many people are in line at time t equal to 300? So you need to consider your initial amount, the amount of people in, so integrate that rate in, and the amount of people that have been taken off, so integrate that rate out. And then C, what is the first time that there are no people in line for the escalator? So you can actually use your information to help with C, because you already found out how many people were in line at time 300. And then we need to consider how many continue to be removed after that time 300. Because we know that at greater than 300, there are no more people coming in. All right, and then part D, at what time is the number of people in line a minimum? So again, think of your justifications. For minimum, our justification is that the derivative goes from negative to positive. And we're talking about our derivative. So we need to first think about what is our setup for the number of people. And our number of people in line is going to be that initial amount plus the amount coming in. So our integrating our minus the amount of people coming out, which would be that 0.7. And we want to look at when it's a minimum. So justification is when the derivative changes from negative to positive. So I want to do the derivative of this, and our derivative of 50 is nothing. Our derivative of this is just RT. And our derivative of this is minus 0.7. So we're looking at where this changes from negative to positive. So we set it equal to 0 and then test it on number 1. Okay, so that's our kind of big idea there. Let's take a look at our scoring guidelines. So if you would like to go ahead and get out a different color pen, color pencil, something to kind of mark Pretend you are the AP grader. You just got some Joe Schmo, Sally Sue's AP for your spots in front of you, and you're grading it. You have the guidelines. You can take a look at the points for it, and then you can kind of see how you do it. Yes.
Why 50?
It's not 50, it's 20.
Okay.
Was it 50 bananas? Was there 50
Yeah.
anywhere? Okay, sorry. 20. Thanks. Let me bring over 2018. All right. So part A was actually 2 points. Sweet. Usually it's like 1 point or something like that. So our answer was 270. Again, you need to have that setup. Always show your setup for your integral. So it was 1 point for our integral, 1 point for our answer. Your integral needs to have 0 to 300, and it needs to have the dt on it. And then our answer was 270 people. Do you have to have this nice long sentence? No. What they're looking for is 270 people entering. Okay. Yes, Jess.
So for A, it's how many people enter, not the total amount, so we didn't add the 20.
Correct. Yes, how many people have entered? Mm-hmm. Now for part B, it says how many people are in line at time 300. So we need to consider the initial amount, that's for 20. And then you might have written this as 2 separate integrals. You could have written this one, I wrote it as 2 separate ones. So we want to consider our initial amount. And then this here is our, this guy, is our amount that added on from 0 to 300, minus the amount that have been exited. So we've got, this is interesting, I don't think I've ever seen this before. They give a point for considering rate out. So for subtracting that 0.7 integrated or that 0.7 times 300, usually they just say like 1 for your setup. So you got 1 point if you did anything with subtracting away that 0.7 times 300 or minus the integral of 0.7 from 0 to 300. And then 1 for your answer. And the answer was 80 people. Okay. Do we have questions on the points breakdown for A or B? So these are the questions that students got last year. Those lucky guys. All right. So now C. This, I think, looks a little confusing. I'm going to show you an alternate way to set this up. So for C, it was just actually 1 point for your answer. The first time that there are no people in line is at 414.286 seconds, or 414.285 seconds. Now you'll notice their work here says 300 plus 80 divided by 0.7. Let's take a look at how we got that, though. Okay, so it says for time greater 300 was the first time that there are no people in line for the escalator. Okay, now from part B, we got that at time 300, there were 80 people in line. So you had a couple of ways that you could have done this. Okay, so for C, it says, was the first time there are no people in line for the escalator, so our amount of people, I'm going to bring this down here. We go back to our original amount. So our number of people in line is, again, that initial amount of our 20. And then we add in the amount that have been added on, which is our integral of our little art TDT. And now that only occurs from time 0 to 300. After that, there is nothing, there are no more people being added in. And then we subtract away the amount of people that have exited. And that's from 0 to our time. And then that would be 0.7. Technically, we should say, instead of t, we should say ds. They don't want the variable to be the same. T represents the time. So what we're saying here is, from time 0, or 0 to whatever time it is, we're looking at, this is the number of people in line at any point in time, past 300. So 20 is our initial, and we have, between time 0 to 300, we have a certain amount of people coming in. And then we have exiting 0 t of our rate 0.7. So when we go ahead and do this, so we're looking at time 300. So basically from part B, we found that 20 plus our amount in, and then part of the amount that exited was 80. So this is from part B. This is from part B. But then we still have people exiting beyond time 300. So this is the amount of people up until 300. But then at time 300, we still have people exiting. Okay, so if you remember to use your information from part B, you didn't have to do this up here. But if you didn't use your information from part B, that's what you would have done here. All right, so we had 80 people at time 300, but then we still have people exiting. And so we want to figure out when there are no people. So this is the amount of people at time 300. We still have people exiting. When is that going to equal 0? Or in other words, when is the number of people that are currently in line equal the number of people that are exiting the line? Okay, so when we do this, we get 80 minus our antiderivative is 0.7 evaluated. Evaluated from 300 to T. Oh, thank you. Alright, thank you. So now when we evaluate, we have 80 minus, let's put that from 0.7 T minus 0.7 times 300 equals 0. Again, you could have added your 80 or added this over so we have 80 equals that. And so then we have 80 minus 0.7 T plus 0.7 times 300 equals 0. So when we solve for our T then, I have 80 plus 0.7 times 300 equals our 0.7 T. I'm going to divide to get rid of that 0.7. We end up with 80 over 0.7 plus 300 equals our time. This is where their simplified answer. Here was 300 plus 80 divided by 0.7. That was the work for that. Okay, so it's not that you had to have written on your paper exactly just that. Yeah. You don't have to have just that, but I want to show you where that information came from. So again, we already found our time at 300 was 80, and then we needed that our rate between 300 whatever time equaled that amount. So all that to say, 1 point for an answer of 414.286 or 285. They weren't particular about having units for this one, so those are very different. Okay, questions with yes, Charles.
So if you were to do like all the calculations in that calculator, would you just show your setup?
Show your setup, yeah. Yeah, so guys, every time you have a calculator problem, always show your setup, and then you're allowed to do stuff on your calculator, but if you don't have your setup, then you're not going to get the points at all for it. Okay, and then for D, our biggie, so our absolute max and min. This one was an absolute minimum, and they're looking from 0 to 300, so on your chart, they want to see these endpoints. This is going to be part of your justification. And then we also have to find our relative minimums is what we're looking at here. All right. So our justification for minimum is, again, that the derivative, is that our derivative changes from negative to positive. Now, our total number of people is, again, our initial plus the amount in minus the amount leaving. Again, you could have written this instead of 0.7t, you could have done the integral of 0.7 dt and then evaluate it from there. But so our justification says to take the derivative, set it equal to 0, and then check on our sign. When we take our derivative, 20 is nothing. The derivative of our integral here gives us just r of t, and then our derivative of 0.7t gives us the 0.7. So what they're looking for is that you have r of t minus 0.7 equals 0, or r of t equals 0.7. So that gets you a point considering that. And then you get a point for finding the t value of 33.0132. All right, and then you have to check these on your chart. So we had two values here were equal to 0. I think only one of them was actually possibly minimum. I think this was the only possible minimum. And so that's why they didn't give you a point for the other one. They just needed a point for that guy. Okay, so notice that they asked, find the number of people in line at this time. So they asked at what time and find the actual number of people. So they needed not just the time, but also how many people was it. And you have to check how many people. Oh, okay, maybe that's, sorry, I was like, where did 4 come from? They asked for both things, and in order to find your absolute minimum, you need to actually find those values here. And so you're just taking these values and putting them back into the total number of people. So our initial plus that integral there. So you had to find this anyway, but just make sure you actually state it in your answer. To have it on your chart and to not have the statement here is not sufficient. They want you to translate this. If you just throw the chart down in front of Joe Schmo is going to say, what's this for? I don't understand it. So you have to actually answer the question. So our answer was number of people in line is a minimum at time 33. And they rounded to the nearest whole person when there are, I would probably say about 4 people in line. The justification point is for having your chart here. So 1 point for our RT minus 0.7 equals 0, or the RT equals 0.7. 1 point for getting our relative min here. And then 1 point for your answer, 1 point for your justification. Your justification means the chart with those endpoints there. Make sure you label your chart. This is our time, people in line for the escalator, or you could have, I wrote out the integral up top here, either way looking at that. So 4 points for the absolute maximum. I've noticed in the last few years, AP seems to really be emphasizing, or it seems to be that an absolute maximum is somewhere within your first response prompts. Almost guarantee they're going to give you one of those. And I feel like they've been giving a few more points to it, usually like 3, this one was 4 points. The other thing is they feel like in recent years they've started putting in for response questions about IVT and MVT. Now we'll be reviewing that. I think it's 2 classes, but just have to look at that. Okay, so we have a question about the points distribution, please. So again, this is out of 9 points, 4 for D, 1 for C, 2 for B, and 2 for A. So just go right at the top how you did on that. And then let's take a look at our points for 2017, our bananas. Alright, part A was again how many pounds of bananas are removed. So we want the number, so we want to integrate our rate. If we're wanting to integrate, if we want the amount removed, we want to integrate the rate out. So you're integrating at the PDT. Guys, this is another huge thing. Save yourself time. Notice for both of these, they gave us that our function was RT. When you write your integral, just write integral of RT dt. Don't write out the whole big long crazy thing. Call it by its name, use that, save yourself time. Same thing with our bananas. Don't write out the long thing, just say integral of ft dt. Alright, so 1 point for your integral. Again, you have to have the limits and your dt with it. And then 1 point for your answer if 20.051 pounds of bananas are removed during this first 2 hours. Part B, find f prime of 7. So our derivative, this is just straight up on your calculator. You didn't have to do any math. So just make sure you actually label it. F prime of 7 equals negative 8.120. You got a point for that, for just being able to plug that into your calculator. And then it says, explain the meaning of this in the context of the problem. All right, so we want to think back to your justifications. If our first derivative is negative, that means our original function was decreasing. Now, our original function was the rate out. So the rate at which the bananas are being removed is decreasing. So that's what we're going to go with here. So after the store has been open 7 hours, or at time equal to 7, the rate at which bananas are being removed is decreasing by 8.120 pounds per hour per hour. They want those units with that. So always make sure you do the units. So again, think back to your justifications before you even go to answer it. What does it mean if our first term is negative? First term negative means original function decreasing. Our original function for this particular one was the rate at which bananas are being removed. So rate at which bananas are being moved is decreasing at a rate, or you could say it's changing at a rate of negative 8.120 pounds per hour. Or per hour squared. Okay. So 2 for A, 2 for B. Questions with A and B? Alright, so then C, is the number of pounds on display increasing or decreasing at time equal to 5? So again, you have a couple options for this. They went ahead and did, so G was our rate in minus our rate out. You could have found G of 5, found F of 5, and then just decided which one was larger. But they did G of 5 minus F of 5, so our rate in minus our rate out, found it was a negative value. So because it's negative, the number of pounds is decreasing at that time. So that was 1 point for considering each of those individual rates at 5, and then 1 point for your answer. And so if you didn't do G of 5 minus F of 5, you just compared G of 5 and F of 5, make sure you say you would say since F of 5 is greater than G of 5, and the number of pounds is decreasing. Okay. And then D, I feel like this is like the easiest D that I've seen in a long time. So how many pounds of bananas are on the display table? I feel like this is usually a part A type question. So how many pounds are on the table? We have our initial, we have the amount in, and minus the amount out. So you got 2 points for your integrals. Again, make sure you have limits in your DT, limits in DT, and then 1 point for your answer. I think I would have preferred 2017 over 2018. Okay, so again, 3 for D, 2 for C, 2 for B, 2 for A. Go ahead and put your score at the top. And then I want to see with thumbs how we did. Let's start off with our bananas. So thumbs up is like, hey, we did great. We got like a 7, 8, or 9. Thumbs middle is like, oh, we got a 4, 5, or 6. And then thumbs down is, it was like a 0, 1, 2, 3. Hey, a lot of here. That's good. Okay, those of us that are here to hear, do we have any lingering questions? Okay, so that was bananas. What was the other one? Escalator. Show me in thumbs how we do this escalator. Escalator not as good. So we're looking here. Okay. So what threw us off with the escalator? Was it our absolute or was it stuff above?
I think we had it as a piecewise.
That does impact it, yeah. So that must have messed you up then, and once we got past the 300.
Yeah.
That would definitely change things. How did we do the absolute?
I didn't see the 0 cents.
right.
What?
I feel like absolute is often an issue. Okay, so in your packet there, obviously there are 2 other free response questions. So there's 2016 and 15, I believe, right? You're not required to do these. These are just a couple other examples of a rate in, rate out. I would recommend before the AP exam, maybe when you're reviewing, maybe on spring break, you're just really looking for something to do, and so you want to do a rate in, rate out. But they're just in a couple more examples. And this is kind of the setup we'll have each class. We'll do some multiple choice. We'll do some free response, just kind of refresh your memories with this and get an idea. This allows you to kind of see if you need to spend more time on rate in, rate out, or maybe more time on particle motion, things like that. Do you have questions with any of this? So for senior, I said you could have time to work on your cross-section project. If you haven't had me double check that you have your setup correct, you might want to have me do that. But for those that have equilateral triangles, I want to show you how to do that with the compass. Yes.
Do you hear about the carpenter who's working on the job here?
No, I did not hear. What about
Got
it?
it? He got hammered.
You're so funny. Yes. Oh, cross that. Yes. So we got 2, 9, so I'm going to trust your graphs there, right? So we good. Take it away. When you're ahead, so definitely. So the next side is going to be you got the 4 there. Okay. And your equilateral triangles? That's right. So what I'll do is I'll just check this. Because you've got your calculator, so punch it in your calculator, just double check that what you got by hand matches, and you're good. But this all looks good.
I think I realized that they're wrong, but that's the way that I think it's supposed to be. Hold on, so this is my question.
Yeah. Like, it was so strong.
Okay, so we do want to consider top and bottom of the square root. So we have positive square root and negative square root, but your side's correct.
Oh, it is great. Okay.
Because we have the, so it's minus and negatives. Yeah. And then your quarter circles. Okay, so the quarter circles.
Probably literally for quarters of like formulas.
Yeah, I would say drinking.
Right. Going from here to here.
Yeah.
So. Okay.
Oh, was it?
Oh, that's very nice.
The only thing I did.
Okay, so this looks good. So just long I would double check your calculator.
Yeah, I already did that. But let me just ask you, so when I like put them on the thing, the radius like for each quarter circle, so is that gonna like be
Yeah, so your shape that you had here,
I was going to.
here's your quarter circle, right? So you're going to take a ruler or compass, whatever you want. Probably use a compass for that. And you're just going to measure that, and then I would just do like a, either do the full circle and then just cut out a quarter of it. But your height is going to be the same as that there because it is, right, it's a radius this way and a radius that way. Does that make sense?
Can you check mine?
Yes. Okay, hold on, let me pause this here. No, you're fine.